Today we're talking about backup, or sometimes called standby generators. So in the industrial and commercial space, like hospitals, schools, grocery stores, office buildings, they do make very large diesel powered standby generators like this one. However, today we're going to be talking about the residential space, and you have a couple different options. Option one is a permanently installed standby generator, meaning usually it mounts to a pad, like a concrete pad, and you would plumb in a natural gas line or propane line to it. Some of them run on gasoline, some are dual fuel. Generally, these are a little bit more expensive and require professional installation, a permit, etc. I'm going to be focusing on option two, which is a portable standby generator, which, as you can see, as the name implies, it's portable. It has a handle. It has two wheels, so you can wheel it around like a wheelbarrow, basically. Store it away in your garage or your shed when it's not in use. This one is nice. It's a dual fuel. It's push button start. Has solid rubber tires, not pneumatic tires, so you don't have to worry about them going flat. Ones that have the battery start with the push button start, you want to also remember to get a sold separately trickle charger, or sometimes called a battery maintainer, that will maintain the charge on that battery. That way, when you do need your backup generator and you go to start it, you won't have a dead battery on your generator. So just keep that in mind. This particular one is rated for 1,300 watts for $1,049 at Walmart at the time of this recording in December of 2022. Just a quick disclaimer, this video is not a promotion for any company, manufacturer of any generator or anything like that. And just a quick safety note, when you operate your portable generator, you never use a generator indoors. You never run it in your garage, your carport, your house, etc., because the carbon monoxide fumes from the exhaust can kill you. So never run a generator inside. Always needs to be ran outside. And also keep in mind, when you run it outside, don't have it running right outside your kitchen window. If your kitchen window is open, or you're going to leave a screen door open where the exhaust fumes can be sucked inside your house. So just some common sense there. You can go online and do a Google search to figure out what size generator you need. So how many circuits do you want to power on your house? What is your budget for this generator? You can find a watts to kilowatts conversion calculator online, like you see here on the right. You can go to this rapid tables and punch in all the data you know, and it'll tell you how many amps that backup generator is capable of producing. So in this example, again, we're working on AC single phase. It was rated at 10,500 watts. It produces 240 volts. Power factor, leave that at 1. When you hit the green calculate button, it gives us an amperage of 43.75. So you have a couple different connection options. Option one is to simply use some extension cords. I personally don't think that's very practical, because you're going to have a bunch of extension cords running into your house. You got to leave your door cracked open or your window cracked open a little bit. The extension cords are a trip hazard. You know, if it's bad weather outside, you're letting bad weather into your house. Option two is to buy one of these transfer switch kits. They make manual transfer switches like this one that switch back and forth between off and power from the city or power from the generator. And the purpose of these is, again, so that you never backfeed power into the city power lines while you're running your generator. That would be a safety hazard for the lineman. So that's why a transfer switch kit is important. This one costs $319. You can see it comes with the power cord that connects from your generator to the plug that you would install on the side of your house. Keep in mind you would still need to then have wires run from that plug to your transfer switch, and then also from your transfer switch into your circuit breaker panel. So that's additional expense, more time, more complexity. You may need a qualified licensed electrician to do that for you. Option 3 is what they call a GeneraLink. This one's rated for 40 amps and it's meter mounted. Specifically, it mounts behind your meter, between the meter box and the meter, as you can see in the picture. And then the power cord attaches to the bottom of it and then runs over outside to wherever you have your portable generator. But again, these two are expensive and you're going to need a permit for this. You're going to need to contact your electrical power company, let them know that this is something you want to do, get permission, etc. Option 4, this is what I would go with. I plan on doing one of these on my house in the future. It's called an interlock kit. And in the simplest of terms, it's basically a little metal bracket that you slide left to right or up and down, depending on the make and model of your circuit breaker panel. And it prohibits the main breaker on your panel from being on at the same time that the generator breaker is on. So this little metal sliding bracket only allows one or the other to be on at any given time. Because again, we don't want to accidentally backfeed electricity into the city wires while the linemen are working on it. That could be obviously deadly for them. So these interlock kits are simple, relatively inexpensive, easy to use. Just please keep in mind there's not a one size fits all. So you need to look at the make and model of your circuit breaker panel, whether it's Siemens or GE, Square D, etc., and then do a Google search for an interlock kit that fits your specific make and model of circuit breaker panel. That's important. And of course, when you install this, usually they'll come with an installation template, so you know exactly where to drill those 3 holes, where the mounting screws go through. And again, always turn off the power before you perform this work, or hire a qualified professional licensed electrician to do the work for you. And keep in mind, even if you do one of these interlock kits, this one costs, what, $38? You're also going to need to have a 2-pole 50 amp breaker installed in your panel. You're also going to need to buy the power inlet box that you would mount to the outside wall of your house. This one's $37. And then you're also going to need to buy the power cord that connects your generator to the inlet box on the side of your house. These come in different lengths, or if you're handy, you can buy the cord by itself with no ends on it, and then you can buy the plug separately and make it yourself. Personally, I think it's easier, and you know, the cost is negligible as far as the difference between making it yourself or just buying one that's already pre-made. Again, this one is 6-gauge wire. And it's got your actually got 4, even though it's 6'3", what you have inside there is 4 conductors. So you got your neutral, your 2 hots, and your ground. And again, this one's good for 250 volts, 50 amps. So you want to make sure everything has a proper amp rating, right? So if we know our generator is capable of putting out almost 50 amps, then of course we need to make sure our power inlet box is rated for 50 amps. The 2-pole 50 amp breaker, again, rated for 50 amps. The power cord, rated for 50 amps. You get the idea. So again, talking about wire ampacity, as this chart shows, that's why we're going with 6-gauge wire, because it's rated up to 55 amps. You can see if we try to downsize and go with smaller 8-gauge wire, that's only good for 40 amps, so that would not work for this example. So you want to go with a minimum of 6-gauge wire. I hope that makes sense. And you can buy some 6-3 UF wire at Walmart, Lowe's, Home Depot, your local electrical supplier, online, etc. And this one's sold by the foot for $6.98 per foot. And it's got your 3 conductors and your ground. Again, it's 6-gauge wire. And if you look at the specs, it has a minimum order quantity of 6 feet and a max of 250 feet. The conductors are made of copper. It has PVC insulation and a nylon color-coded jacketing. This can be used indoors for wet or corrosive locations. Can also be used outdoors for direct burial. Jacketed with sunlight, moisture, and fungus-resistant gray PVC. So some of the legal, technical stuff. The NEC requirements for generators and standby power systems is Rule 220.87, Articles 445, 700, 701, and 702. Again, you need to ask your local authority having jurisdiction in your area, do I need a permit to do this? And then the other question, can I install it myself? Do I have the skills and experience and knowledge and tools to do that safely? Or does the installation have to be done by a licensed electrician? Your local authority having jurisdiction may even tell you you have to have it done by a licensed electrician. So that would be an additional cost you'd want to factor in if you're thinking about buying a backup generator for your house. I hope this information helps. Please like, share, subscribe, leave me a comment for future video topics you would like me to cover. Thanks for watching.